Today I'll be explaining handwriting recognition neural network implemented with Python. So at first we import TensorFlow, which will be primarily using, and TensorFlow is Google's machine learning or deep learning library. So we import TensorFlow as TF. Then we import our dataset, and we are using MNEST Handwriting Dataset, which is a pretty large dataset having thousands of handwriting digits. Then we prepare our data for training. In here we load our data, then we normalize that data to 0 and 1 because of easier calculation, and so we divide the X train and test models by 255s. Then we encode labels to X and Y, which is train and test. Then we reshape our data for our neural network. Then we finally create a neural network, which is from Keras, and the method is sequential. Then we create our convolution layer, which is consists of 32 filters using 3x3 kernel matrices, and we give the image as 20x28 pixel grid, and our monochrome color value, which is the color depth, and the activation function is ReLU. Then in the next step we poll at the rate of 2x2 matrices. So polling is basically a method of stripping out unnecessary data, and polling basically keeps the maximum values and discards the rest. And the next step, we flatten our layers into a single layer, and next we implement our hidden layer, which is a dense hidden layer, and which has 1 to 128 unit, which is a neuron, and they have and having ReLU activation functions. Another thing we have to keep in mind that the overfitting issue can occur, so we have to drop out the neural networks that are causing or overfitting, which will be 0.5. So this neural networks having the values of 0.5 will be discarded or deleted. And the final step, we are implementing our output layer, which is a dense output and having 10 units for our 10 digits, and the activation function having the softmax method. Then we compile the neural network using Adno optimizer, and the loss function being a categorical concept therapy, and the matrices are accurate mode. Then we feed our model with 10 epochs or 10 iterations, and we evaluate our model, and if we finally give our phylum in our arguments, then the model will be saved into our disk. So let's have a look at it. So if we run this model, here's the file handwriting. So if we run this model, we're going to give it some time. We can see that our neural network is going through about 1875 samples. It will take some time, so I'll be back. So we can see that our training is complete, and our loss is 0.4%, and our accuracy is pretty good at 98th percentile range. And we can also see that our model is saved to a disk. So here is our model inside our assets model folder inside our current folder. So here's a saved model, and this is about it, and thank you.